I think most people can intuitively see that the conversion of complex numbers to polar coordinates is going to follow the same path as the conversion of real numbers to polar coordinates. So I'm not really going to spend so much time on this. This is really going to be more of going over polar coordinates again. So there really isn't so much to talk about. So I've got an angle, I have an x-axis, I have a y-axis, but in this case, since I'm dealing with complex numbers, it just so happens that these are going to have an I on them. This is some z point. The standard form is z is equal to x plus yi. Now, if this were not complex numbers, we already know how to do this. It's really simple. So if I want to find my x component, I'm going to use cosine of theta. Cosine of theta is equal to the adjacent side, which is x over r. And then I can simplify this. So x is equal to r cosine theta. And the y is just as simple. The y component is this opposite side, so sine theta is equal to y over r. Now, I could put yi there, but I just never bother. For me, I just think of the I, it's just carry-on baggage. I just kind of, at the beginning of the problem, I just check that with the plane, I do my problem, then I go pick up my baggage at the end of it. If I can put an I there, it doesn't really matter. I think it's just more simple just to think of it in terms of, in just pure distance terms, really. That's what I'm trying to find when I am using all of these graphs. So I'm just going to ignore this I, and I'm just going to add it at the end. So multiply y is equal to r sine theta. And then r is equal to the modulus of z, which is equal to the square root of x squared plus y squared. So I've got all my information I need to convert something. This could be 2 and 4i or minus 4i. It doesn't matter. Whatever it is, I can use these to, let me just write it into a simple formula. So z is equal to x, so let's just put it into this, x plus y, z is equal to, into the standard form. So this would, what standard form would look like for polar coordinates. Z is equal to x, which is equal to r cosine theta plus y, so r sine theta. And the only difference between the regular coordinates and the complex ones are this has an I on it, so I just stick an I here. And then actually I can write this nicer. I can factor out an r cosine theta plus I sine theta. So this is the conversion. Oops. Very simple. Even Simple Jack could do it. No problem. Just do it like a regular conversion to polar coordinates problem, and then just slap an I on that bad boy. And that's it.